Sarah and Jared are discussing the solutions to this equation. Who do you agree with? So obviously they already have these like answers over here. But if you were going to go about solving this and you didn't have answer choices, okay, the first thing that you would do is you would factor this guy, which would be x plus 1 and x minus 1. We learned yesterday and Tuesday that it has to have the same denominator before we can do anything when it's adding and subtracting. Okay, so on here, what we're going to do is we're going to take this fraction and multiply by x minus 1 in the top and the bottom, and this fraction and multiply by x plus 1 in the top and the bottom. Okay, now since they're all the same thing, you can take just the tops and multiply it out. If we distributed all this junk and we solved, again, we probably would get -1 and -2. What do we have to do at the very end when we solve? Like after we solve, we got to check our solution. Okay. So what we're going to do is we're going to take our two choices and we're going to plug in. Where do we care about? Is it the numerator or the denominator that we care with these solutions?
The denominator.
Denominator. We cannot have it equal 0, right? So if we take -1 and we plug it into this one right here, that's going to give us -1 plus 1. That's a no-no, right? So Jared is already wrong. Okay. Now we could check Sarah. We could take -2 and plug it in, and it works on both sides. So Sarah would be correct. Okay, so you always got to make sure that you check your solutions.
Both.
Steven plays basketball for his high school team. So far, his team has won 12 out of the 20 games. How many games will Steven have to win in a row to improve his team's winning percentage to 75%? But right now, we got 12 out of the 20 games, right? Okay, so that's 60, right? But we want to get to 75%, right? Okay, so we need to add some number of games out of the total of 20 to equal 75%. Now, can we solve this, John? Yeah.
Wait, hold on.
If we added it to the bottom as well, what would we get? Could you solve that? X's won't cancel because you're adding it to something, right? Okay. Because I said the same thing on mine. I was like, when you add it to the bottom, but this is out of 20 games in total. Yeah. So they've played 12.
They won 12, 20, but if they played another,
Okay, so let's solve it that way too, because this morning I solved it different. So let's solve it this way. So what are we going to do first? We're going to multiply by 20 plus x on both the top and the bottom, right? Dude. These will cancel, and I'm going to get 12 plus x equals, what's 0.75 times 20? 0.75 times 20 is 15 plus 0.75 x. Now, how do we go about solving this one?
Why would you multiply it by 20 plus x?
Because 20 plus x down here, we're trying to get this out of the denominator. So 20 plus x. So this is going to give me x equals 3 plus 0.75 x. And then we're going to move that 0.75 to the other side. And so that's going to give me 0.25 x equals 3. If we divide it by 0.25 on both sides, be 12 games. Yep. Ready? Working together, it takes Sam, Jenna, and Francisco 2 hours to paint one room. Okay, so on your paper, I would say Sam plus Jenna plus Francisco, it takes 2 hours. When Sam works alone, he can paint one room in 6 hours. So Sam can do it in 6 hours, and Jenna can do it in 4 hours.
Dang.
Okay, how long would it take for Francisco to paint one room on his own? Okay, so this question is a little weird. Okay, but what we're going to do is we're going to create a rational equation in order to help us solve this. We're going to say, since Sam can paint one room in 6 hours, we're going to say 1/6 plus Jenna can do one room in 4 hours, plus we don't know Francisco, so we're going to say 1/f. And they're painting one room in 2 hours, right? That's an F. So sorry. But yeah, it's getting worse. What? Because it's one room in 6 hours. Yeah. Yeah, and since we're dealing with rational functions, it's gotta have the variable on the bottom. Yes. Okay. So now we're gonna solve this. What do we know about adding fractions? What do we know about adding fractions?
They had to have a common denominator.
It has to have a common denominator. So this is gonna be multiplied by 2 over here. This guy is gonna be multiplied by 3 over here. And this guy is gonna be multiplied by 12 right here. This guy is gonna be multiplied by 6 over here. And 3 in the bottom, 12 in the bottom. And what's one thing we do have to multiply by across?
One.
F.
I'm sorry.
You need a nap.
I'm sorry.
A nap. Okay, so this would give me 2F plus 3F plus 12 equals 6F. And we can go ahead and drop bottom because they're all the same, right?
You should just do that also.
I don't know what to say. Okay, so then we're gonna combine like terms. And then we're gonna move that 5F to the other side. So we're gonna subtract 5. And so F is going to be 12. Francisco takes forever to paint this room. Oh, okay. I called him Francois on the last. I'm gonna find the zeros. What I'm gonna do, hey, ready? Okay, then I'm gonna take this and set this equal to 0. Okay. Now, when I solve for this, I'm gonna add 3 to both sides. And so this is gonna give me 3 equals 1 divided by x plus 2. So, in order for me to get x out of the denominator, then I'm going to get x plus 2 on both sides and multiply. So these will cancel. And I'm left with 3 times x plus 2. So that's going to give me 3x plus 6 equals 1. And now I'm going to subtract 6. Yep. And then divide by 3. So that's going to be x equals -5/3. This is telling me that there is an x-intercept at -5/3. So a doctor prescribes, I'm talking about medicine. Okay, a doctor.
Jordan?
Cool. A doctor prescribes an antibiotic and a steroid to a patient. Concentration of the medicine in the body for the antibiotic can be modified by this function. And the concentration of the medicine in the body for the steroid can be modified by this function. For each function, the time is measured in hours. If the patient takes both of them at the same time, determine when the concentrations will be equal. So what this actually is asking you to do is take each equation and then just set them equal to each other and then solve. That's all it's asking you to do. It looked really complicated for no reason, right? Yeah, that's T. Yeah. So what we're going to do is we're going to factor the denominator. That's going to give me T plus 4 and T minus 4. So what is this missing over here? T minus 4. So we're going to multiply that in the top and the bottom. Over here, we've got T plus 4. Since the denominators are all the same, we can drop the denominator. We can drop the denominator, which is going to give us 29 equals 2 times everything that we hear. That's going to be 2t minus 8. We're going to multiply this out, and that's going to give me 3t plus 12. We're going to combine like terms, so that's going to give me 5t plus 4 equals 29. We'll subtract 4 and then divide by 5. So t is going to equal 5.